Hello, students. I hope you had a great break, and we are back at it here in the first week of January. So for this class and this assignment, we're going to go to the Google Classroom, and we're going to click on Classwork. And you're going to see your weekly schedule and your at-home learning assignment. And it's called Sound Simulators. And we're going to click on that. And it'll open it up in a new tab. So what you'll see here, drag that to the right side of the screen where it says directions, and that's going to take you to the PhET software, which we've used in the past. And we're going to set up our simulator like the picture below. So we'll click on sound because we're in the sound unit. And we'll double click that. And your screen will look like this with the simulator. And it says to set up your simulator so that it looks like this. So the first thing we're going to do, we're going to switch from waves to particles. And we want to make sure it's on top view and normal. So then it says to push the green button here on the speaker. And you can see that when you push the green button, waves travel out and away from the speaker. Follow the motion of one of the red dots. Does the red dot, which represents an atom, move all the way across the screen? And the screen that it's talking about is this dark gray area. Or does it stay in the same area? So let's watch this red dot right here. We can see that it's shifting back and forth as the sound comes off the speaker. But that red dot is staying in about the same area. So when we look at number 4, it does mostly stay in the same area. And then we want you to explain that in your own words. Then click the button to show the graph and click slow motion at the bottom. So I'm going to click on graph. And I'm going to click on slow. And that is slowing down the particles, and it's slowing down how often the speaker moves. So we'll switch that back to normal so you can see the difference. That's what it's like on normal. This is what it's like on slow. And then you'll want to move forward. Are the crests of the waves where the atoms are bunched up or where the atoms are spread apart? Now, if you're having a hard time understanding this question because there's so much going on, you can go ahead and click pause, and then that will show you. So as the speaker pushes out, what do we see here? And then what else is located where these humps are, or the tops of the waves, also known as the amplitude and the crest. So the amplitude is the height of the wave, and the crest is the very highest point. So then we'll go back. Now, once you hit pause, this blue button also turns on, and this allows you to move it frame by frame. So you can slow it down to make more accurate observations on how the atoms are behaving. So when we go to the second page where it says directions, click here on the akidimo.org. And it's going to open up the virtual oscilloscope, which I currently have on this side of the screen. And the top of the page will say virtual oscilloscope. Now, an oscilloscope is really cool because it analyzes sound and actually shows their frequencies. I'll give you an example of 2 different kinds of frequencies based off my voice. This is currently reacting to my voice. You can see how different that these act. Now, since I'm using my microphone, it went to a live input. I want to change that to this wave here. And I want to change the frequency to 442. And then click off. And it's asking you to analyze how many crests there are, which the crest is the top of the wave. So how many crests do I have? And then the troughs are the bottom part of the wave, the lowest point. The amplitude is the height of the wave, and the wavelength is the distance measured from crest to crest. Now I'm going to, for question 5, it's asking me to change the frequency from 442 to 931. And then click off and you'll see it adjust. How many crests are there now? So which frequency had more waves, 442 or 931? You'll just have to look back at your questions 3 through 6 to be able to answer that one as well. Page 3 asks you to click on this link from Soundwave's Virtual Lab. And that's going to come up here. And it's asking you to set up the simulator, like the picture on the right. So for right here, which it's already at, and describe the wave. So I'm just going to click play. Now I'll put the trombone at position 7. I'm going to click on the arrows, or you can manually slide it. And we're going to listen to the wave. And you'll want to look up here, and this will show you the different wavelengths. So here's position 7. Here's position 1. How do they look different? And you're going to use that information to answer questions 1 through 8. And then down here, we're going to click on the link. And we will start talking about the properties of waves. The wavelength of a wave. One of the basic characteristics of a wave is its wavelength. This is the distance from one peak or crest to crest. This is the same as the distance from one dip or trough to the next. So we want to go through the interactive activity and fill out the correct answers in the spaces below after you check them for the wavelength. And you'll just pick these 3 categories. And then the directions are here for questions 1 through 3. Same thing, click the link. How sound travels from NASA. And then the reflection is just going to be based on what you've learned so far in the lab. And these should be written in complete sentences in order to receive full credit. And these should also be in your own words. Let us know if you have any questions. You can contact us in class, or if it's on a virtual learning day for you, then you can send us an email and we will respond to you as quick as we can. Thank you. Stay safe out there and remember to wash your hands.